Complaining.
We're smarter.
Everything's gonna work out. In the end, we're all be in the same spot. It's gonna be fine. So I'm not worried. All right. So liquid. So we got our table here, and then we had our 4 liquids. So we had this one is vinegar. Then we had water. And then this one's gonna be a little more flat, and that's gonna be our ethanol. And then this one is acetone, which is basically just like a line. So there's our acetone. So that's where we left off. We did the demo twice, where I poured the 4 liquids out. Vinegar and water really bubble up very well. Ethanol and acetone are more flat. The reason for that is vinegar and water have stronger forces. Yes?
Just you had to do this on the whiteboard.
Yeah, yes, I do remember that now. We just never put it in our notes, right?
Yeah.
Right. Okay, so these two have much stronger forces than these two. Vinegar has the strongest intermolecular forces. So that was the whole point, is that you guys understood acetone and ethanol evaporate very quickly, so they have the weakest forces. If a liquid doesn't stay together very long and it evaporates quickly and easily, it should make sense to you that their forces are being broken. Remember, handshakes are what I use as a force, right? That's my analogy. So if we were all holding hands together, all right, imagine we were all made of helium, okay? Except Tyler's made of lead, okay? If you guys are all holding hands, and someone's holding Tyler's hand, some of you might be floating up near the ceiling, but if you're all holding hands, let's say we're outside. We're all holding hands, and Tyler is like an anchor holding us down. No one's going to fly off into space. But what if Tyler lets go?
All of us will.
You're all going to fly away. And if you guys all let go of each other, what's going to happen? You're going to disperse like a gas, right? Or a vapor. So the analogy is when liquid particles are holding hands, that's when they're in the liquid form. The longer they can hold on to each other's hands, that's the stronger they are. That should make sense.
Solid, they hug.
And when they become a solid, they hug. That's right. There you go. Because hug, you got to bring it in. Get closer. I like that. So the liquids, again, that stay liquid. So water stays liquid for a long time in this room. It does evaporate, but it's slow. That's because it has pretty strong forces. Whereas you guys saw the acetone evaporate right in front of your eyes. Correct? You remember that, hopefully? It was evaporating. I had to pour more out just so I could light it on fire. So that should help you understand why I wrote these the way I did. Now let's put some dots above them. Vinegar is only going to have a couple. That dot represents the vapor. Okay, water might have a couple more. All right, and then ethanol will have a whole bunch. And then acetone will have literally like an unlimited number of dots. The point of this is that because acetone is evaporating so much and so fast, there's going to be a lot of vapor above it. That was the whole point of that demonstration we did a couple times.
Do you have another demonstration?
And to watch
We
fire.
do, but
Here today, don't worry.
no, it's happening. I got the hot plates on. I'm gonna. All the demonstration is I'm boiling 3 liquids, but you're gonna see the boiling points on the iPad so you can compare the 3, and then we're going to relate it to Table H. So I'm using it to kind of teach this and Table H. So, so you guys with me on this?
Yeah.
Everybody with me here? I hope, yes? Okay, so this one's the weakest. It produces the most vapor. It evaporates very quickly. That's why we can say it has the weakest out of these 4. This one's the strongest. Water's really close, but that one's the strongest. Okay. This one here also has the lowest vapor pressure. Vapor pressure is the y-axis on Table H. You can measure vapor pressure. If it's in a sealed container, you can measure it, kind of like gas pressure or air pressure in a tire. You can measure it with a device or a probe or whatever, okay, pressure sensor. You can measure it. So if you could trap vapor, then you can measure the vapor pressure. Acetone has the highest vapor pressure. Silas, tell us why it makes sense that vinegar would have the lowest, but acetone is the highest.
Vinegar produces less vapor, and acetone produces a lot.
That's it. If you have a lot of vapor, the vapor is going to do this. What is that?
Each other.
Colliding, right. What causes air pressure? Air particles colliding. What causes gas pressure? Gas particles colliding. What causes vapor pressure? Vapor pressure or vapor particles colliding. So if there's a lot of vapor, it's going to have a lot of collisions, so the vapor pressure is going to keep going up. And if it only has a little bit of vapor, there's not going to be very much pressure. Again, the analogy of like bouncy balls. All right. If I had 2 bouncy balls and I gave one to Will, and I have one, and we slam them into the ground, they may never collide. But if all of us have 2 handfuls of bouncy balls, we spike them into the ground, chances are they're going to be bouncy balls bouncing off each other all over the place. That's the analogy. If there's more particles, there's a better chance of collision. That increases vapor pressure. So I'm not giving you a whole lot of notes and definitions right now because I don't think it's relevant. I think it's better to see the demo and then understand our drawing. That helps you learn this. That's my hope. All right, let's go back and watch liquids boil.
Okay.